Okay, so in this lesson, we're going to look at solving polynomial equations. And so some of the polynomials will be quadratic, some will be cubic, and then there's probably going to be one that's going to be of degree 4. But for the most part, they will be quadratic or cubic. So let's look at the first example. So number 1, we have 3x cubed minus 75x equals 0. I'm going to solve this polynomial equation. Now this polynomial equation, the degree is 3, the largest exponent is 3. First of all, just as you did before, make sure it's in descending order. So you have the largest exponent listed, and then the next one is x to the first. So there are only two terms here. And just like you did when you solved polynomial equations, we are going to use factoring. Okay, so we're going to use factoring in this case, so that way we can use the zero factor property. So if you look at this, the GCF of these two terms, the GCF on the left side is 3x. All right, so 3x, so that's the GCF. So I can factor out at 3x, so I get 3x times, and 3x times x squared is 3x cubed, and then minus 3x times a negative, what's that, 25 is negative 75x. Okay, now this is where we're at. So again, you want to solve these polynomial equations by factoring. So you got to make sure you factor completely. So you see this factor right here, that x squared minus 25. You need to notice that that is the difference of two squares. So I can factor it further. Okay, so you want to solve these polynomial equations by factoring. And so if I factor this further, I get 3x times, and remember that's the difference of two squares, so I get x minus 5 times x plus 5 is equal to 0. Okay? All right, so if you look at what you have here, you basically have 4 factors. You have a factor of 3, you have a factor of x, you have a factor of x minus 5, and you have a factor of x plus 5. So remember, when you're factoring, you're rewriting your factors as a product. So we have 3 times x minus 5 times x plus 5. Okay. Now, remember, once you factor, remember you have to have 0 on the other side because we want to use the zero factor principle. Okay? And so remember the zero factor principle states that if you have 2 or more factors whose product is 0, so let's say if a times b is equal to 0, then in order for that product to be 0, then one of these has to be 0. One of the factors has to be 0. So either a is 0, then either a is 0 or b is 0. And so we learned this in a previous lesson, and so we can apply it here. Now remember, just as you did in the previous lesson, we always tend to look at the monomial factor together. So we see you have those two monomial factors, 3 and x. So let's just consider that as one monomial factor. So we get 3x is equal to 0. So I'm setting each of these factors equal to 0. So if you need to underline your factors that you're going to set equal to 0, then go ahead and do so. So think of, even though this right here is two factors, a factor of 3 and a factor of x, let's just consider that as 1. So we get 3x equals 0, x minus 5 equals 0, and then over here we have x plus 5 equals 0. And then notice that you end up with 3 linear factors. And so if 3x equals 0, then that means that x has to equal 0, right? Because look, if you have 3x equals 0, to get x by itself, you're going to divide both sides by 3. 3 divided by 3 is 1. 1 times x is x. And 0 divided by 3 is 0. Okay? But many students, they know that if 3 times x equals 0, then therefore x has to equal 0. Same thing here. You have enough experience to know that if x minus 5 equals 0, then x has to equal 5, right? So, and for some of you, you may need to notice that, hey, I'm subtracting 5. The opposite of subtracting 5 is to add 5. I mean, if you want to do that, you can as well. If you want to write in that stuff, that's fine. And over here, same thing. So it's easy enough to where if you see that you have this equation, x plus 5 equals 0, then the solution has to be x equal negative 5. Okay? So you have three solutions here. You have 0, 5, and negative 5. So those are your solutions. So your solutions are 0, 5, and negative 5. And again, just as before, if you want to check your solutions, you can. Now, when it comes time for a test, you probably will not have time to check your solutions because your test is timed. But for a worksheet or My Math Lab or just practice, you have time to check it. Now, remember, when you check, you always go back to the original problem, not the factor part, because you could have messed up here. You could have made a mistake somewhere. So always go back to the original. So basically, you're just going to check each of your solutions. And I'm going to do it just for this one. I'm not going to do it for any others. But you're just going to do this. You're going to say, all right, let's check and see if x equals 0 works. So you go back, and where we see the variable x in the original, you substitute 0. So I get 3 times 0 cubed minus 75 times 0. And you want to see if that's going to equal the right-hand side, which is 0. Well, 0 cubed is 0. 0 times 3 is 0, right? And then negative 75 times 0 is 0. And so 0 minus 75 is 0. I'm sorry. 0 minus 0 is 0. And do the same thing with 5. So if you want to check x equal 5, then again you go back, and where we see the variable x in the original, you substitute 5. So I get 3 times 5 cubed minus 75 times 5. And I want to see if that's going to equal 0. Use your calculator with that if you need to. 5 raised to the third power. So 5 raised to the third power times 3, okay, minus 75 times 5. All right, and notice you get 0. So you get this right here to be 0, and that does equal 0. And then for negative 5, you can do the same thing. X equaled negative 5. Wherever you see the variable x, you substitute negative 5. So I get 3 times negative 5 cubed minus 75 times negative 5. And you want to see if that's going to equal 0. And so if you use your calculator, I'm actually going to go ahead and do each term just to show you. So 3 times negative 5 raised to the third, just like this, equal, so you see this term right here is negative 375. Over here, a negative 75 times a negative 3, I'm sorry, negative 5 rather, that gives me a positive 375, right? And so a negative 375 plus a positive 375 is 0. Okay? All right, so those are your three solutions. So notice that in these lessons that pertain to this topic we're talking about, you're solving these polynomial equations by factoring, which involves using the zero factor property. Okay, so that was number 1. Let's look at number 2. So number two, let's suppose we had this for number 2. We have 2n cubed minus 3n squared minus 32n plus 48. All right, so notice in this particular case, you have this polynomial that has 4 terms. And so recall, I'm sorry, I got to have equals 0. I forgot an equation right here, right? Okay, so I have this polynomial equation now. And so notice that this polynomial that's on the left-hand side has 4 terms. Okay, it is in descending order, so that's something we want to look to see if we have. So it is in descending order, n to the third, n squared, n, and then your constants listed last. And notice you do have 0 on the other side. The fact that 0 is on the other side is important because that's the only way we can use the zero factor property. So if 0 is on the other side. Okay? All right, so let's go ahead and check to see what the GCF is. So if you look at these 4 terms, the GCF is 1. So now I'm going to go directly to grouping. I'm going to group the first 2. I'm going to group the last 2. From the first group, I can factor out an n squared. So I get n squared times 2n, right? So n squared times 2n is 2n cubed minus 3. because n squared times a negative 3 is a negative 3n squared. In the second group, I'm going to go ahead and factor out a negative, what's that, 16? And so I get negative 16 times 2n is negative 32n, and then negative 16 times a negative 3 is a positive 48, and that's equals 0. And notice that if it's factorable, then these two groups should have a common factor, and they do. See that 2n minus 3? So I'm going to go ahead and factor out a 2n minus 3, just like this, and I get n squared minus 16. So when I factor out the 2n minus 3, you have an n squared, and then you have a minus 16, and that's equals 0. Okay, now remember, when you solve equations by factoring, when you solve a polynomial equation by factoring, you got to make sure that your factors are not factorable any further. Okay, so if you look at n squared minus 16, notice that that's the difference of two squares, just like you notice it over here. All right, so you need to go further with it. So let's go further with this. Now I can't do anything further with 2n minus 3, so I'm going to leave that alone. And so over here, I'm going to get 2n minus 3 times, and then that's going to be n minus 4 times n plus 4, and that's equal to 0. So notice in this polynomial equation, I ended up factoring as 3 factors. All right, so I have 3 factors whose product is 0. So according to the 0 factor property, one of these factors must be 0. And so if you recall, what we do is we set each of these factors equal to 0. So you end up with 3 linear equations. 3 linear equations, and you got to show all this. And so at that point, almost all of you know that, for instance, over here, that if n minus 4 equals 0, then that means that n has to equal 4 when you solve for n. Over here, if n plus 4 equals 0, then that means that n has to equal negative 4, right? Because negative 4 plus 4 is 0. Over here, 4 minus 4 is 0. Over here, if you have to, then just go ahead and do it step by step. So you may say, well, I need to get 2n by itself, so I've got to add 3 to both sides. That's true. So I get 2n equal 3. And then to get n by itself, you can divide both sides by 2, right? And so therefore, n equals 3/2. And so those are your 3 solutions. So your solutions are, and on the blank you'll say n equals 3/2, n equals 4, and n equals negative 4. Okay. Now, just remember in my math lab, if they ask you for your solutions and separated by commas, what that means is this. They're probably going to have something like this, like a set notation with that brace. And so all you do is put the numerical solution in here. Don't put n equal 3/2. Don't put this in here for my math lab. All right. So in my math lab, they just want the numerical solutions, the real numbers here. So you just say 3/2, comma, 4, comma, negative 4. All right. So if you put the variables in here, it's not going to recognize this, even though this is correct. In my math lab, they just want these. Okay. So be careful so you don't lose points just because you put something in there that you did not need to. All right, number 3. So let's get number 3. Number 3, we have x minus 6 times x plus 5 is equal to 12x. So x minus 6 times x plus 5 equal to 12x. Now be a little bit careful with this, the 0 factor property, because some of you see this as a product, and so you want to set each one equal to this. But remember, you're overgeneralizing when you do that. So you got to remember that whenever you set each factor equal to the other side, that has to be 0. All right. So that idea only applies if that's 0. So if you have a product, and if you want to set each of those factors equal to that side has to be 0. So what you got to do first then is you got to multiply this out, FOIL this out. So you're going to make it look like a polynomial written in terms. just like that. So you can make it look like a polynomial. All right, so you have x times x is x squared. Your outer is 5x. I'm using the FOIL method here. The inner is negative 6x. And then the last, a negative 6 times positive 5 is a negative 30. And that's equal to 12x. Let's combine like terms first over here on the left side. So I get x squared minus x minus 30 equal 12x. And so now, remember, you want to, if you're going to solve this polynomial equation, which is equivalent to this has to be in standard form. So basically, you're going to put all your terms on one side, and you need 0 on the other, and we're going to put it in descending order. So I'm going to subtract 12x from both sides, and notice I'm aligning my like terms. So I get x squared, a negative x, and a negative 12x is a negative 13x minus 30, and that's going to equal, and then 12x and a negative 12x is 0. And now I can factor. So when I factor this, I'm going to get, I think I may have, let me just verify this. Okay, so we're good. All right, so then I'm going to factor this. And so when I factor this, I'm going to get let's see, 30. So that'll be 15 and 2. Last sign is negative. That means these signs in here are different. And notice that I want a negative 13x. And so if I want that to be negative, the middle sign to be negative, that means that the 15 would have to be negative, and the 2 would have to be positive. And just double check before you go on. So make sure you get this trinomial right here. So x times x is x squared. A negative 5 times a positive 2 is a negative 30. The outer is 2x. The inner is negative 15x. And 2x and a negative 15x, negative 13x. And so now, so I factor this, and so now I can use the zero factor property. So I'm going to set each of these factors equal to 0. And so when I set each of those factors equal to 0, I get this. I get x minus 15 is equal to 0, and then x plus 2 is equal to 0. So I have these two linear equations. And so if x minus 15 equals 0, to get x by itself, I'm going to have to add 15 to both sides, so I get x to be 15. Over here, I'm going to have to subtract 2 from both sides, and so I get x to be negative 2. So these are your two solutions. So your solutions are x equal 15, x equal negative 2. And just remember, my math lab, you're just going to put 15, comma, negative 2. All right. Okay, number 4. Number 4, we have 3x plus 4 times 2x squared minus x minus 20 equals 0. And so if you notice, so that kind of throws students off a little when it looks like this, because when you factor, or when you set each factor equals 0, you tend, if you notice, if you go back to all our problems, each factor was a linear factor. It was the largest exponent was a 1, x to the first power. If you look at this factor is a trinomial, and the largest exponent is a 2. So basically what you're going to try and do at that point, just like if I had just this right here. So if you just had this, what would you do? You would try and factor this, right? So that's what you do. You try and factor this. So if you try to factor this, and this right here is 3x plus 4, let's see what we get. So I'm going to try and factor this right here. And don't forget that's equal to 0. So I get 2x, x, for 20, there's 5 and 4, 10 and 2, 20 and 1. And notice, let's try 5 and 4, see what happens. So let's put the 5 here, the 4 there. I know, and remember, you know you can't put the 4 there based on our discussions in the past, because if you put the 4 there, that means you could factor out a 2, which means that all of these are divisible by 2, and negative 1 is not divisible by 2. So 4 has to go here, 5 has to go here. The last sign is negative, so that means you're going to have different signs. So what's going to work will be, let's see, that's let me make sure I put this one correct, because I could have messed up that one. So let's see. I think I may have messed up that problem to begin with. Okay, so yeah, I did mess up that problem, guys. So this should be a 3 right here. I apologize. That's a 3. All right, so that's a 3 right here. So I did leave the 3 off. So you have 2x squared minus 3x minus 20. So that means that if I want this middle term to be negative 3, that means that the 4 would have to be negative and the 5 would have to be positive. And so let's double check. So the first 2x times x is 2x squared. The last 5 times a negative 4 is a negative 20. The outer is a negative 8x. The inner is a positive 5x. And when I add them up, I do get negative 3x. All right. So just go back and make sure you change that to negative 3, negative 3x. So now I can set each of those factors equal to 0. So when I set each of those factors equal to 0, using the zero factor property, I get 3x plus 4 equals 0. 2x plus 5 equals 0, and then x minus 4 equals 0. So notice that I have these three equations, and they're all linear. And so to get the variable x by itself, here I'm going to subtract 4 from both sides. Combine like terms, I'm going to get 3x equal negative 4, and divide both sides by 3. One of my solutions is negative 4/3. Over here, subtract 5 from both sides, combine like terms. I get 2x equal negative 5, divide by 2. I get x to be negative 5/2. Over here, add 4 to both sides, and so x equal 4. So those are your three solutions. So your three solutions are negative 4/3, negative 5/2, that's 5/2 right here, and then 4. Okay? All right, let's do number 5. Number 5, let's suppose we had this in number 5. Okay, so number 5, we have this. We have x to the 4th minus 16 equal 0. Okay, so I need for you to recognize that this polynomial equation, you already have 0 on the other side, okay? But the left-hand side, there are two terms. And I want you to notice that this right here is the difference of two squares. Because I want you to think about this. So let's think about the difference of two squares. So this is the difference of two squares because I can fill in these parentheses. So for example, if I look at this one here, what times itself is 16? Okay, 4. Over here, what times itself is x to the 4th? Well, x squared. So that's the difference of two squares. So that means that x to the 4th minus 16 can be factored as x squared minus 4 times x squared plus 4. And don't forget, that's equal to 0. Okay, at that point, you want to try, just like if you go back to all your problems you've done, if you go back to all your problems, all your factors, before you use the zero factor property, all those factors were linear factors, x to the first, x to the first. Here, these two factors, your largest exponent is 2. So you want to try to factor further if you can. So if you notice, this right here is still the difference of two squares. So I can factor that further. So I get x minus 2 times x plus 2. Over here, notice that's the sum of two squares. The sum of two squares I can't factor, so I'm going to have to rewrite this as it is. Okay? All right, now, look what we have. We have three factors. 1, 2, 3. So if you have three factors whose product is 0, then one of those factors has to be 0, right? So I'm going to go ahead and set each one equal to 0. So that's a zero factor property. So I'm going to set this one equal to 0. So x minus 2 equals 0. So in order for this factor to be 0, then that means that x has to equal 2. Okay? Because think about it. 2 minus 2 is 0, right? In order for this factor to equal to 0, what do you think x would need to be? Negative 2. So you subtract 2 from both sides, combine like terms, you get x to be negative 2. Okay? All right. Now, here's the one we got to talk about. X squared plus 4. I want you to think about this. Is x squared plus 4, if I substitute any real number, remember you're solving You're trying to find any real solutions. So if I substitute any real number into x, will this ever be 0? So some of you may say, well, what about negative 2? Okay, what's negative 2 times itself? Negative 2 times itself is 4. 4 plus 4 is 8. It's not 0. If you try 2, 2 times 2 is 4. 4 plus 4 is still 8, right? So I want you to notice this. If I subtract 4 from both sides, I get x squared equal a negative 4. Think about all your experiences you've done before. If x is negative and I square it, what kind of number is that? That's a positive number, right? So is a negative number times itself ever going to be negative? No. If x is positive and I square it, what kind of number do I get? A positive number. So a positive number squared is never negative. If x is 0 and I square it, what do I get? 0. Well, that's not negative either. So here's a question I'm going to ask you. Is x squared ever going to be negative? Nope. It's never going to be negative. So this right here is never, so x squared plus 4 is never equal to 0. So that means this. That means that the only solutions I'm going to have will be these two. Those are the only solutions. So the solutions are only x equal 2 and x equal negative 2. So those are the only solutions. This right here is not going to give me any solutions because that's never going to be 0. Now, let me just say this. In a future lesson, you're gonna solve this kind of equation using imaginary numbers. Okay, but for right now, in these lessons right here, in these topics, we're only looking for real numbers, not imaginary numbers. So a lot of you may remember the word imaginary. Okay, so you're going to see later on that the solutions here are imaginary, not real. So those are the only two real solutions. Okay? All right, number 6. So let's do number 6. So in number 6, I have x squared plus 6x minus 87. And that's going to equal 4 times x minus 6. All right, so x squared plus 6x minus 87 equals 4 times x minus 6. Okay, so just as you did in one of the previous problems, I think it was number 3. So remember, in number 3, see how it looks like this is already factored? And then some of you would have the inclination to set each factor equal to this on this side, but you're overgeneralizing. If you set each of these equal to 12x, you're not going to get your solutions. It's not, whatever you have will not be a solution to this. In order for that 0 factor property to apply, that has to be 0. So we ended up foiling this, multiplying these two binomials out. And so we ended up with a polynomial, and then we factored that, and then we were able to set equal to 0 because that was a 0 right here. Same thing here. Notice, do you see a 0 on the other side? Nope, do not see a 0, right? So we got to bring all of these to this side. Before I do that, though, let's go ahead let's go ahead and distribute this. So I'm going to distribute the 4. So I get x squared plus 6x minus 87 equal 4x minus 24. And now you're going to bring all the terms to one side. So I'm going to subtract 4x just like this. And so I'm doing one thing at a time. So I'm subtracting 4x, and then notice I'm aligning my like terms. And then I'm going to add those. X squared, 6x and a negative 4x is a positive 2x minus 87 equal, this is 0, a negative 24. Then I'm going to add 24 to both sides. So notice again, I'm aligning my like terms. And so I get x squared plus 2x. And then that should be, let's see, negative 87 plus 24 is a negative 63. And that's equal to 0. So now what do you think you can do next? What do you think is the next thing you're going to do? All right, so yes, you're going to factor that now. So the GCF is 1, so I'm going to go directly to the two binomials, make sure you say equals 0. And so x times x is x squared, negative 63, that's 9 and 7, right? So let's put a 9, a 7. The last sign is negative, that means these signs are different. So look at your middle sign. You want that to be a positive, right? And in fact, it's a positive 2x you want. Do you see which one you're gonna make positive, which one you're gonna make negative? Okay, so yes, this will be positive, this will be the negative. And again, before you go any further, always check x times x is x squared. The last positive 9 times the negative 7 is a negative 63. The outer is a negative 7x. The inner is a positive 9x. And when I add them up, I do get 2x. And so now you can use the zero factor property. So I have two factors whose product is 0. Then one of these has to be 0. So you said each one equal to 0. And you're basically asking yourself, for what value of x is this equal to 0? Okay, negative 9, right? So if you subtract 9, you get x to be negative 9. So that's one of your solutions. Over here, to get x by itself, you're going to add 7 to both sides, so you get x equals 7. So basically what you found are the two values of x that will make this product equal to 0. So if x is 7, let's say, 9 plus 7, what's that? 16. 7 minus 7 is 0. What's 16 times 0? 0. Negative 9. Negative 9 and a negative 7 is a negative 16. Negative 9 plus 9 is 0. 0 times a negative 16 is 0. Okay, so those work. All right, so number 7. Okay, number 7, let's suppose we have this in number 7. Okay, number 7, we have 2x minus 3 squared equal 23x minus 11. That's 11. 11x. Okay, that's 11x. All right, so just as before, if you think about this right here, isn't that kind of, if I can get back to it, isn't that kind of like this where you have a product of two binomials? Because if you remember, 2x minus 3 squared means 2x minus 3 times 2x minus 3, right? And that equals over here 23 minus 11x. So you're going to do this one just like you did, what was it? Number 3. Just like you did this one. Okay, so let's FOIL this out since you have product of two binomials. So 2x times 2x is 4x squared. The outer is a, what's that, negative 6x? The inner is also a negative 6x. And then the last, a negative 3 times a negative 3 is a positive 9. And just remember when we dealt with binomial squares, that when you FOILed it, the out and the inner has to be the same. So that's what you see here. The out and the inner are the same. And so that's going to equal 23 minus 11x. Okay, now let's combine like terms on this side. So I get 4x squared minus 12x, because negative 6x and a negative 6x is a negative 12x, plus 9, and that's going to equal 23 minus 11x. Okay, let's go ahead and put this in standard form, and let's put in descending order. So I'm bringing all the terms to the left-hand side, because remember, in order to use the zero factor property, one side has to be 0. So let's go ahead and subtract 23 from both sides. So I get 4x squared minus 12x. 9 and a negative 23, what does that give you? That gives you, what's that, negative 24, is that right? And then that's going to equal, I'm sorry, not negative 24, excuse me, negative 14, negative 14. And that's going to equal negative 11x, because that's 0. Okay, now adding 11x to both sides, and let's go ahead and align my like terms. I'm going to get 4x squared, negative 12x, and a positive 11x is a negative x, and then minus 14 equal, and then that's 0. Okay, so now let's go ahead and factor this. Let's see, that should have, I kind of messed this up again, didn't I? Hold on, let me just check this one moment. Okay, so I think I'm good with this. So this is factorable right here. So let's go ahead and factor this. So I'm going to get 4x and x. I'm not going to do 2x and 2x because it's not going to work, but 4x and x will. And for 14, let's use 7 and 2. And notice if I use 7 and 2, will I put the 2 here? No, you're not going to put the 2 here because remember on previous lessons, if you put the 2 here, that means you can factor out a 2, which means that each of these are divisible by 2, and negative 1 is not divisible by 2. So you can put the 2 here, and you're going to put the 7 here. And so now if the last sign's negative, so the last sign's negative, these signs are different, and notice you want a negative of 1x here, so you want this to be negative. So in order for that to happen, then that means the 2 has to be negative, and the 7 has to be positive. And then always double check. 4x times a negative 2 is a negative 8x. 7 times x is a positive 7x. I'm going to add them up, I get negative x. All right. And now I can use the zero factor property because I have two factors whose product is 0. So one of them has to be 0. So I set each one equal to 0, just like this. And notice that what you see is that you have these two linear equations. And so to solve this one, you're going to subtract 7 from both sides, combine like terms. I get 4x equal negative 7. So to get x by itself, remember right now you're multiplying by 4. The opposite of multiplying by 4 is to divide by 4. And so one of your solutions is negative 7/4. That's one of them. Over here, that one's easy enough to where you can get that quick. So you add 2 to both sides. Your other solution is 2. So those are your two solutions. Okay, and then finally, let's look at number 8. Number 8. So number 8, we have, let's see, 36x cubed minus 27x squared equal 16x minus 12. Okay, so 16x minus 12. Okay, now, so notice I have this polynomial. I have variables, I have terms on both sides. You want to solve this polynomial equation by factoring. And then remember, if you're going to solve it by factoring, you're going to be using the zero factor property, which means that this side or this side, doesn't matter, but one of your sides has to be 0. So let's go ahead and take those two terms and bring them to the other side. So right now this is a positive 16x. To get rid of them, let's subtract 16x from both sides, just like this. And then notice that though all these three terms here are different, they're not like terms. So far I have this. I have 36x cubed minus 27x squared minus 16x. This is 0 equal negative 12. Then adding 12 to both sides. Again, all these four terms are different. They're not like terms, so I can't combine them. But I do end up with 36x cubed minus 27x squared minus 16x plus 12 is equal to 0. And now I have four terms. Let's see, the GCF is 1. I have four terms, so I'm going to do this by grouping. And so in the first group, it looks like I can factor out a 9x squared, right? And when I factor out the 9x squared times, what's that, 4x? Is that correct? Okay, so 4x is 36x cubed, and then 9x squared times a negative 3 is a negative 27x squared. Over here, I'm going to factor out a negative, in this case 4, and I get negative 4 times 4x is a negative 16x, and negative 4 times a negative 3 is a positive 12, and don't forget all that's equal to 0. And notice that if this is factorable and I'm doing this correct, then these two groups have to have the same factor, and they do, 4x minus 3. So I'm going to factor out the 4x minus 3. And when I do that, when I factor out the 4x minus 3, I get 9x squared, and then minus 4, and that's equal to 0. And so notice, just like you did before, notice that these two factors, the first one's linear. Remember, every problem we've done, we ended up with linear factors, except for the one that was, if you go back, the one that was the, I may have misplaced it somewhere, but remember the one that was the sum of two squares? Yeah, the sum of two squares. All right, so this right here, though, is the difference of two squares. So I can factor that further. So I get 4x minus 3 times, and then this would be 3x minus 2 times 3x plus 2, because that's the difference of two squares. And that's equal to 0. So notice that each of those factors are linear now. Those are linear factors, x to the first, x to the first, x to the first. Okay, so now I have three factors whose product is 0. So I'm going to set each of those equal to 0. And so I get 4x minus 3 equals 0. And then let's go ahead and solve for this one right now. So to solve this linear equation for x, I'm going to add 3 to both sides. Combine like terms, I get 4x equal 3. And then to get x by itself, right now multiplying by 4, the opposite is to divide by 4. 4 divided by 4 is 1. 1 times x is x, so your solution is 3/4. That's one of them. Over here, 3x minus 2 equals 0. So adding 2 to both sides, and then combine like terms, I get 3x equal 2. To get x by itself, right now multiplying by 3, the opposite is to divide by 3. So remember, you got to divide both sides. But you do one side, you do the other. And so 1 times x is x, and then that's 2/3. And over here, we get 3x plus 2 equals 0. Subtract 2 from both sides. You're going to get, and combine like terms, that's 0 right here. So you get 3x equal negative 2. So to get x by itself, right now you're multiplying by 3. The opposite is to divide by 3. And so 3 divided by 3 is 1. 1 times x is x. So you get x to be negative 2/3. And so those are your three solutions: 3/4, 2/3, negative 2/3. Now, a couple of remarks I want to make before we go on. Notice if you go back over all these 8 problems, the factored part right here, all of these were linear. Okay, all of those were linear. Go back, notice linear times linear. So you ended up with 2 linear equations. Okay. Now, let me say this though. So you might say, well, it wasn't linear. Yes, you do remember, whenever you get to this point, and if this is not linear, then see if you can factor it further. So this right here is the difference of 2 squares, so I could factor it further. Okay, that's important to do. And then notice that this right here, when I factored it, it was automatically 2 linear factors. Okay, over here, notice that our original problem was a linear factor times a trinomial, so I had to end up factoring this trinomial into 2 linear. And so notice I have these 3 factors that's set equal to 0. Over here, we ended up with a trinomial that factored into 2 linear factors, so you set each one equal to 0. Okay. Over here, number 6, same thing. You ended up with 2 linear factors. You set each one equal to 0. Now this is the one where you got to go back and look at again. So I had this original problem that was the difference of 2 squares, so I factored it. One of these factors was still the difference of 2 squares, so you went further because that's not linear. That's quadratic. That's x squared. So you factor it further. This right here, though, that's the sum of 2 squares, which you cannot factor. So that means then is that if you try to get x by itself, see how I got x squared equal negative 4? Then that's where we had the discussion that x squared is never going to be negative. X squared is always positive or 0. So a negative squared is positive, a positive squared is positive, 0 squared 0. It's never negative. We're also going to talk about this in a later section. Some of you may remember the word imaginary. So when we solve this, this is actually going to be imaginary solutions. But in this lesson, we're only looking for real solutions. Okay? All right, so that is the end of this lesson dealing with solving polynomial equations by factoring.